Hi folks, Professor Buckley here. This is MEEG102, the lecture for Tuesday, March 31st. If you're watching it a little early, good for you. I wanted to get this up there because there have been some questions about how we're going to do online lectures and all the other supports around it. So welcome to online MEEG102 officially. A couple announcements. Exam number 1 is going to be this coming Thursday. So that is Thursday, April 2nd. The exam is going to be proctored over Zoom. We're going to do a review session today during this lecture. And we're also going to practice a Zoom session. I'm saying today, assuming that you're watching this on Tuesday, March 31st. If you're watching it a little early, that practice Zoom session will be on Tuesday, March 31st from 10:15 to 10:45 a.m. Okay, so you can hop on with your proctor and practice at least getting set up for the exam. They won't do any problems during that time, but it will be a good chance for you to practice what the proctoring session would look like. Make sure that you're comfortable in that environment so there are no surprises related to how you're taking the exam on Thursday, April 2nd. Okay, my office hours are posted to Canvas as well as the TA's office hours, so please check that. I know there have been a lot of questions about assignments that are due and how we can best support you. Please check those office hours and take advantage of them. Speaking of assignments, individual assignments, assignment number 4 is going to be due at midnight on Friday, April 3rd. Okay, so that assignment was assigned to half of the class officially before we transitioned to online classes and had our extended spring break. The other half of the class, it was not given at that time, but we feel that this will give you enough time to complete this work. I really want you to try to complete assignment number 4 before the midterm because it's a really good prep for what will be on this exam number 1 midterm. Okay, please with your individual assignments, if you're having issues with SolidWorks, utilize IT support. You can also reach out to your lab section teaching assistant and they can help you, help direct you over to IT or maybe help you with the problem themselves. They are not IT support, but we do have lots and lots of IT support available now that we have moved to online classes. Moving our way through these extended announcements here, the design project. The design project is going to be a paper design. We're going to continue with our design project, which is to create an awesome toy for Melissa and Doug. Melissa and Doug obviously will not be coming to campus. We will not be on campus, but I'm hoping that we can showcase to our sponsors who are still very much engaged with the class exactly what you guys are doing. So by paper design, what I mean is that you are going to create detailed drawing files for these engineering drawing files for these toys that you're coming up with. You'll be able to validate some aspects of the design completely electronically on paper. Obviously, we will not be prototyping because you cannot be in the design studio right now. We're very sad about that, but we will make sure that all of you, a class of, 2023, have plenty of access to the design studio and those hands-on experiences as soon as we get back to in-person classes. I promise, you have my word. Okay, milestone number 5, which was assigned before we transitioned to online classes. Milestone number 5, which is metrics, is due midnight on Friday the 3rd. You can sense a pattern here. Pretty much everything that we need to get caught up in the class is due Friday, April 3rd. Okay. Milestone number 6 is assigned right now. Okay, so you heard it first from me. It's assigned, it's open. This is concept generation and selection. It is going to be due next week during your lab section. So just like when you had in-person lab sections are going to be completely virtual, but people who have lab sections on Tuesday will have that experience. We're encouraging you to have that experience on Tuesday, and those who are on Thursday will be on Thursday. There will be teaching assistants standing by in their office hour rooms on Zoom during those lab periods for you to ask any questions and share your screen, and they can coach you through it. Okay, but your assignments going forward will be due like they were in in-person classes during your, at the beginning of your lab section, excuse me. Okay, honors. Your second reflection is due midnight Friday, April 3rd. Okay, so hopefully you had a lot of time over the break to read the second half of the book Makers. I enjoyed reading your first set of reflections. I'm sure I'll enjoy reading the second one, and then I think we can arrange a Zoom session optional for you guys to come, and maybe we'll do virtual coffee hour where we can also discuss the book. There will be one more element after you finish your second reflection. There will be one more element, which is a maker profile that will start probably next week is when I'm going to release that. Okay, last but certainly not least, I want to make sure that you guys have the opportunity to interact with me in person, not just in person virtually, of course, but not just over YouTube. So I will be starting next week. This is very important. Next week, Tuesdays and Thursdays from 11:30 or 10:30 to 11 a.m. So the last 15 minutes of technically this class period, extending up until my office hours, are going to be dedicated to questions around this class in particular. So I will send you the link. Okay, and you guys can hop on a special Zoom room that I've created for discussions about whatever was covered in that day's lecture via YouTube. Okay, so a little bit of live time with me, and then for those of you who've already taken advantage of my regular office hours, they are starting next week as well, but my regular office hours have always been Mondays from 10 to 11 and Tuesdays from 11 to 12. Those will still be in effect, and that's when you can talk to me about anything that's going on. Okay, so those will be general open discussions, but that 10:30 to 11 a.m. Tuesday, Thursday, starting next week, will be protected time for you to interact with me related to the content of this course. Okay, it will not be open office hours. It will be related to the content of this course. All right, I think we're through all of the announcements right now. I will do at the end of this this lecture, I will talk a lot about what we're going to do for the exam. Okay, so there's more details coming in this lecture on the exam, but what I want to do now is I want to flip over and I want to run through some exam study guide problems. So I've had an exam study guide released since before our extended spring break. Okay, if you work through a chunk of problems from there, as well as make sure that you cover at least a good chunk of assignment number 4, you should be in very good shape for your first midterm exam. But I want to take the time here to work through 3 problems with you that kind of give a sampling of what the course is all about to this point. So I'd like to offer a suggestion for how to utilize this YouTube session, which is for you to, I'm going to start by presenting the problem. I want you to read the problem that's on the screen, which is straight from the study guide. Maybe you find it in the study guide yourself, and then you put me on pause, and you should work the problem on your own first. Okay, I can't stress this enough. There is absolutely no value in you watching me complete these problems like I'm some TV show here. Okay, so complete it on your own. And then restart the video, so take me off of pause and review your work with me. So I'm going to go through and I'm going to solve the problem, and then we'll discuss the rubrics that are associated with it. Okay, so it's going to end with the rubric that will be used to grade problems of that type on the exam, so you should know exactly where we're giving points and where we're taking points off, and it'll be super beneficial. But this only works, guys, if you are taking advantage of the opportunity to practice yourself and not just listening to me as if I'm a TV show. Okay, with that, I'm going to give you a second. We're going to do 3 problems together. This first problem is worth about 25 points. That's what I'd give it on the exam. And I'd expect it to take you about 20 minutes to complete thoroughly, okay? So this involves creating dimension engineering drawings from a provided isometric view that's on grid paper. The grid is always a 1/4 inch. I'll tell you if it's anything different. I'll also tell you that it's a 1/4 inch. I'd like you to specify your dimensions to 2 decimal places. And also there's a note here, do not assume isometric image has the correct front view, okay? So I want to see a orthographic projection and then have that fully dimensioned for this object. Okay, now is a good time to put me on pause and work the problem on your own. right, folks. So I'm going to start working this problem. Hopefully at this point you have completed the work on your own, or you've gotten to a point where maybe you're stuck and you've been stuck for more than 20 minutes. So now is a good chance to look at this together then. Okay, and I'm going to start by creating the isometric or the orthographic projection. So this guy here, I'm going to start by thinking about this as, do I have the correct front view? And actually, this is not a bad choice for the front view. I think so front view would be this direction. Looking at this object from this perspective as the front gives the general shape, l'essence of the part, okay? Looking down like this, I'd have some hidden lines. This way, it would not show the circular feature, right? So I'm seeing the hole here in profile on this one. So I'm going to leave it be. I think it's a decent shot for the front view here. If you wanted to reorient this somehow and flip it upright, that would be fine too. That is totally your choice as specified in the problem. Okay, but I'm going to leave it as is, which means this is the front view. So I'm going to start by sketching that front view, and I need to take some dimensions. So I've got 1 inch by 1.5 inches, okay? So I'm gonna first kind of create 1 inch. That looks a little big. Okay, so on the exam, we're asking you not to use rulers. We can tell if you do that, okay? So this is a 1/2 inch over, so I'm just getting kind of the general shape here. And then 1, 2 gets me to the center of that circle. And then 1, 2 gets me to the outer edge. Okay, there's going to be a lot of sketching here. Okay, and one thing I want to make sure is that when you're sketching, that we can tell the difference between your final object lines and your sketch lines. So you'll see in a sec, I'm going to go back through and I'm going to really make sure that I erase that. I erase all my sketch lines so that I've got a clear shape. Okay, and then I've got here in the middle, I've got a little circle that's going to be a 1/2 inch. Okay. Now we don't expect you to go over in pen, okay, but I do expect to be able to distinguish, especially what you're going to do on the exam is actually scan to PDF. Okay, so I want to be able to distinguish solid object lines from sketch lines, okay, so that's going to be super important. Okay, so that's a decent front view. I need to make sure that I include my center lines, right? So I want to make sure that those are included. I have that extend off the object. Okay, and that looks pretty good for the front view. Now I'm going to come on up here and I'm going to sketch. I'm going to leave a little bit of room, okay? So this guy is going to be 1 inch, and then I've got a nice line I can utilize here to give me that outer dimension. And this is going to be kind of L-shaped, right? So 1, 2, 3, 4. I'll come over. This guy comes up. And then this guy's going to be 1/2. Okay, again, I'm expecting this problem to take you guys about 20 minutes, 20 to 25 minutes to do. Okay, so I'm obviously working through a little bit faster here, and that's okay. So I've got myself a hole, and that's going to show up as a hidden line there. And then this guy, this notch comes in 1/4 inch, so that's going to show up like that, right? Okay, and again, making sure that I've erased all the lines that I don't need. I've got hidden lines where I need hidden lines, the hole, and this notch feature that's going to come in a little bit. I've also got my center line there. Maybe I'll darken that up a little bit. I've got my center line there for that hole, okay? All right, last bit here. Remember, I will never fault you for including a third view. I would like to see a third view on this one. This is not a simple, straightforward part, so I'd like to see that. Okay, so 1, 2, 3, 4, it's going to be 1 inch. It's going to look about like that. Okay, and it looks a little narrow. Actually, I'll come out a little bit. this guy's going to come in 1/4 inch. So that's going to be a cutout. And then I've got a hard line there that sits back. Okay, I've got this guy. And then this is not going to be there anymore, right? So I'm going to get rid of that. Okay, so let me go over these lines just to make sure they're extra crisp when I wind up turning this in. Okay. All right, that looks pretty good for my orthographic projection. Now I need to start dimensioning, right? Here comes the tricky part. All right, so as we talked about in class, I like to start dimensioning by thinking about the overall dimensions on the part, sort of the gift box that I would wrap this piece in. So I'm going to start here with this gift box. And this is similar to a problem that we worked together in class when we were still in person, in that I've got this rounded top that is flush with the sides. Okay, so that's going to prescribe this outer dimension here. It's going to do a lot of work for me. So I'm actually going to start by giving this guy, just so I'm sure that I'm not redundant. Okay, so I'll prescribe it as a radius. You could do it as a diameter as well. That radius on this is going to be 0.50, right? Okay, so that gives me this dimension. So now here to here is prescribed, right? So here to here is prescribed. And it also gives me here to here. So I need to be careful that I don't over dimension this part now. So I'm going to start by coming out to this center here. So that winds up being 1, 2, 3, 4. So that would be 1. I want 2 decimal places. Okay, this guy here is 0.50. Okay, then I've got this guy that's giving me this outer dimension as well. I'm going to go ahead and, this is kind of now getting into features, but I'm going to go ahead and do the notch. I'm going to do the notch as what's coming on the sides, these little tabs. You have multiple options for doing that. Okay. So just so long as you don't over dimension, right? So if I were to give all 3 of these, that would add up to twice the radius here, and that would be an over dimensioned part. Okay, so make sure you understand that. All right. So this is the overall shape, right, on this front feature. I've taken care of everything I can take care of on the front. If you want, I'll do one more feature here, which is this hole. Okay, so this hole is diameter 0.5, right? And I want to dimension it as a diameter because it is over 180 degrees. Okay. All right, let's go up on this part. So again, my first priority is overall dimensions. So I need to specify the thickness of each of this L shape, right? So this is kind of similar to what we have to do on the Lego blocks, right? Or the puzzle cubes. So this is 1, right? And then this guy would be 1/2. Okay. Now at this point, let me make sure I've kind of got everything. I am missing something, which is actually the depth of this notch, right? So that notch, this guy here, I could dimension it in a couple ways. So I could give the depth of the notch off of this, but that would be dimensioning off of a hidden line. The depth isn't taken care of on this part. It gives me the width, but I would probably do the depth here, right? So I would come up like this and do something that says, hey, that's 0.25 deep. All right. So that would be a complete problem. Let me run through one last time that I've got all outer dimensions. Okay, so I know the total length of this part in this dimension. I've got this guy is covering the total height. I've got this guy taking care of the L shape. Now features. Okay, so first feature is, let's talk about this hole. So this hole is located in X and Y. Okay, the y is located by the fact that this radius is splitting this part in two, and I've given the diameter there. This notch, I'm giving this dimension here, the height, let's say, on that piece, and then the depth is covered on this guy over here. Okay, I've got center lines marking my circular features in all instances, so I think I'm good. Okay, so let's flip over for a sec. We're going to go back to the problem statement, and I'd like to go over the rubric. Okay, so the rubric here that we would use to evaluate a problem like this is looking at both the orthographic projection and the dimensioning. And the split tends to be, for a 25-point problem, we would probably assign 10 points to the orthographic projection and about 15 points to dimensioning. Full marks is obviously 100% on that problem, so the full 25 points. Minimally acceptable tends to be right at that cutoff between a D and an F, right? So that would be like a D- grade, which is 0.7 times the number of points awarded. Okay, so that would be like 14, 15 points, okay? All right, so you obviously want to be on this side of things, okay? So what are we looking for in the orthographic projection? Correct choice of front view, front, right, and top are all aligned, okay? I've done that. All features, edges, and hidden lines are shown. Okay, so I've got my hidden lines where I need them. I have my feature lines where I need them. I actually have a mistake here on this version of it. Okay, you'll see that this first version, this should kind of actually sit out a little bit, so I would actually not be quite full marks for this one little feature here. Maybe I'd lose a point for that, okay? So center lines on all views, I've got those. Clear scale with no distortion, and the drawing is neat. Okay, we've got that as well. So I can clearly distinguish line types. Okay, dimensioning wise, dimensions as shown would make manufacture as easy as possible. Okay, so I'm making sure that my dimensions are clear and they're not cluttered. Contains all dimensions necessary to manufacture, no dimension redundancy. Dimensions are clean and readable, making use of spacing, nesting, and leader lines when appropriate. Okay, so this has all of those characteristics. And what we're looking for subdividing under here are things like, are your, have you done the overall shape of the object? Are you locating and describing each and every feature? Okay, so that goes inside of that as well. Okay, so I want you to take a look at your own drawing and think about how you did on this part. The drawing that I worked through with you, that would be 100%. As one potential solution. Okay, there's a couple different ways that you could do the dimensioning. Obviously, we'd also talked about a couple different ways that you could position the part and still have the correct front view. Okay, those would all result in full points. So think about how you did on this. 100% full marks, perfect. 90% is tending towards full marks, one minor mistake. Okay, so I would probably have something maybe a little bit above a 90 on mine for this error. I've actually got two errors here on this version of my drawing. I've got missing, this line should be out a little bit. Okay, so there should be another line here for that feature that's only a ½ inch in. That notch only goes, I'm sorry, a ¼ inch in. And then I need to describe that notch as well, right? So I need to describe that depth, so I missed that. So actually that probably puts me at around 0.9 points on this problem. Okay, tending towards minimally acceptable. Okay, so this is, we've got two levels in between. You got several minor mistakes, so maybe I did this, but then I also forgot to describe a couple things about this hole. Maybe I forgot to actually locate the hole, or I forgot another center line. Okay, 70%, I've got a big mistake, one or more major mistakes, or sorry, more than one major mistake. 40% is you did some attempt, but you didn't, really you're pretty far off, and 0 is obviously you didn't do anything on the problem. Okay, and then we have kind of scales in between, but these are the big jumps, okay, that we're looking at. So give yourself a score, please, on this particular problem, and then we'll move on to the next one. Go ahead and write your score on your page. I'm going to ask you to turn one of these problems in as class participation at the end, okay? All right. So put me on pause if you need to, otherwise I'm moving forward. Let's tackle another problem from your exam review packet. This is problem number 2. Okay, so problem number 2 involves describing how you would make a solid model of this part. So this is a little suction toy, bathtub toy that you can use to suction up against the walls. It's made out of rubber. I'm saying describe how you would create a solid model of the suction cup toy. Ignore the texturing on the centerpiece. So the texturing are these little nubs. You don't need to worry about them. For reference, each cup is about 1 inch in diameter. Okay, so it's giving you some sense of scale for how big this thing is. Okay, so let us go ahead and work on this problem. I'm going to flip over to the document camera again. Okay, so suction cup toy. Well, I am actually going to start with this center piece here. Okay, so I'm going to start with the ball in the center. I'm going to, if I haven't described it, I'm not going to knock you down for assuming it's hollow or assuming that it's filled. I'm going to just go ahead and assume that it is hollow and it's got a certain thickness, right? Because you probably wouldn't want that much rubber there. Maybe it's a little bit of a squeezy ball. Okay, but we'll get to that in a sec. So step one, I'm going to work on that center sphere. And I'm going to start by sketching a circle and a line. Okay, so I'll say sketch, circle, and sketch line. Okay, next is I'm going to revolve the circle, right, to create a sphere. That's a word I want to see, revolve. Now we're in 3D, right? So revolve the circle to create the sphere. Next thing I'm going to do, I'm actually going to come back to, so I like to label my steps. Now I got to kind of think about, well, actually, let me do this. Then I'm going to, step 3 is shell sphere to make hollow. So the sphere is going to be, it's going to have a shell in it. Okay, so now that's sphered, that's shelled. Cool. Okay, step 4, I need to start focusing on these suction cups, right? Okay, and I'm open to interpretation on this, but what I'm going to do, what I would suggest doing, is go back to sketch plane in 1. Okay, so go back to my first sketch plane, and I am going to create, so my first sketch plane had that circle, it had a line coming down. That line would split this bottom suction cup in the middle, so I would go ahead and sketch this line. So I'm going to label it sketch curved line. Now I'm just going to focus on this piece. Okay, so I could say focus on this, revolve curved line around, what's that, y-axis line. Okay, so that would give me, this is the y-axis, right? That would give me, here's the base of the sphere. That would give me this guy kind of doing this. Here's my original line. And it's going to revolve around this to create this suction cup. Right? Now the base of this, base is flat. So you need it to maybe shell to create that inner suction cup. The other thing you could do, and here's where I'm open to interpretation. So you could say, hey, this is going to be a shell to this curved surface, right? And that would create something like this, right? We've shelled it. Or I would also say you could do some sort of, here's where we're getting into more advanced SolidWorks features, but you could actually do a cut. You could put another sphere there and cut down. But I would guess, most of what I would accept here would be a shell operation on the inside, okay? Or if you miss that part, it's like 1 point off that you haven't created an actual suction, okay? So I'll call this step 5 and this step 6. And then the last step, 7, is going to be to replicate the suction cups 3 times, right? So you're going to basically create, you've got your suction cup down here. It's got its shelled feature, and you're going to create 2 more of those here and here, okay? Replicate that guy, 3x on 120-degree spacing. Okay, and that's pretty much it, guys. So that gives us all the features. So let's kind of talk about what features are, or what steps here are the most critical, right? There's some of these that are kind of details and other that are essential. Getting this sphere in the center by rotating a circle is an important step. Okay, making it hollow would be a detail if you think that that's what's going on there. I really didn't describe it. Doing another revolve feature to give you these circular, this profile here, right? Recognizing that that's a curve that's been revolved around. That would be essential. Actually curving the inside of the suction cup through a shell feature or something like that, that's a detail, okay? So that, that wouldn't be worth as much, okay? Replicating, recognizing that you're replicating is also important. So I'm expecting to see 2 revolves and a replication for this problem. Okay, so that is kind of the ideal solution. Let's take a look. We're going to flip back to the slideshow here. Okay, and here would be some work that I've done. Okay, and how would I look at this problem? Well, what we're looking for here, so each of these types of problems where I'm asking you to describe solid modeling steps, there are going to be multiple solutions, right? So what really matters to us is that you're describing the steps clearly using terminology from solid modeling operations. The steps will create the part as shown in general, okay? We're not looking for every last little detail, but the big features, the fact that this had 3 of these little suction cups and this was a sphere in the center, that's what we're going to want to see. Neatly sketched and annotated, so I'm very clearly marching you through all of the steps. I'm drawing a little sketch each time. Okay, that's what we're looking for. Problems that we see on this are when things are unclear, so the descriptions are unclear, or the steps that you're specifying really aren't going to create a part that generally looks like the part that we're asking you to. Okay, also messy work with annotations needed but not provided. Okay, so again, this is full points and this would be minimally acceptable. Okay, so I want you to think about how you did on this problem with your own work. Okay, what I've provided for you is basically perfect. Okay, so that would be full marks. Minimally acceptable has these characteristics, and then there's obviously levels in between. So kind of think about how you did on this problem. Give yourself a score, write that on your paper. Again, I'll be calling for one of these to be submitted for the class participation in this lecture. Okay. Last one, guys. We've got one more problem that we're going to do together. Okay. Take a minute to appreciate this problem. This would be a 10-point problem as stated. I might ask you a similar problem, but it'll be a little heavier weighted. I'd expect about 10 minutes, so the number of points on my exams is typically about the number of minutes that I'm thinking it's going to take you to get through it. Okay, what I'm asking here is for you to apply the prescribed tolerances to determine the minimum and maximum dimensions for reference dimensions A and B. Okay, so we've got A here and B here. What are the minimum and maximum values for those dimensions given the other dimensions on that view as described, okay? A couple other notes on this problem. This would be in inches, obviously, okay? I would like you to specify your outcomes to 3 decimal places. So I'll make sure that that's on the exam, that I've clarified those points. So 3 decimal places, please. Okay, start working on this on your own, and then I will jump in. Okay, now that you solved the problem on your own, let's work on this together. So I'm going to start with A because that makes the most sense. Okay, so A is this dimension here. A is equal to nominally this dimension 2.0 minus this guy 1.00. Okay, so that's kind of the equation that I'm working with. A min is going to be equal to the minimum value for this dimension, applying the tolerances, minus the maximum value for this dimension, applying the tolerances. So the minimum value for 2, applying the tolerances, would be 2.0 minus its associated tolerance. So 0.0 gives me 0.05, okay, so 5 thousandths, minus 1.00, whoops, 1.00, plus, in this instance, its associated tolerance, which is 0.01, right? Okay, so when I solve this, I wind up getting 0.94. And then again, I requested 3 decimals. Okay, so let's write that down on the notes. 3 decimals, exclamation point. Okay, A max is going to be equal to the maximum value of this with its tolerance minus the minimum value of this guy with its associated tolerance. So that would be 2.0 plus 0.05 minus 1.00 minus 0.01, okay? And that winds up getting me 1.06. Cool. Okay, let me do B. So B, the easiest way to get B is going to be to say, okay, I'm going to have this dimension of 1.00 minus a half, right? So this is the diameter, a half, so just the radius of a half, which is specified fractionally. Okay, so B min is equal to the minimum value of this minus the maximum value of this. So that would be 1.00 minus 0.01 minus a half of 1/2 plus, in this instance, it's going to be 1/32. Here's where 3 decimal places really matters. When I do my calculations on this, I get 0.724. Okay, B max is equal to 1.00 plus 0.01, right? So the maximum value of this minus the minimum value of this guy. It's 1/2 minus 1/32. Okay, and my value there is 776. Okay, nothing more to the problem than that, folks. Let's see how you did, okay, and how we're going to evaluate this. Here's my work again. So the work shown, so full points, work shown that applies correct principles for calculating max or min, okay, uses appropriate tolerance from the title block, and correct math. That's what we're looking for. So minimally acceptable is one major mistake, okay, such as incorrect principle applied. So let's say that instead of calculating B min as the minimum value here minus the maximum value here, you had the maximum value here minus the minimum value, okay? So that doing that once out of all 4 of these would bring you down, okay? Or you did not use the appropriate tolerances from the title block. So if you didn't pull 1/32 here, 0.01 for 2 decimal places, 0.05 for 1 decimal place, that would be another major mistake, okay? So again, I want you to think about how you did on this problem, okay? This would be a 10-point problem, 100%, 10 points, perfect, like I showed, okay? 70%, one major mistake, and then working your way through the others that are in the middle. So mark your problem here and see how you did. Okay, now it's time for you guys to turn in your class participation. we're going to do exam problem number 1 from this lecture. So again, that was this problem, this guy here. I want to see your work on this guy and your score. Okay, so how did you score on that first big problem, that 25-point problem? Submit your work that you just completed for exam problem number 1, exam problem number 1, including your self-assessed score. We're going to practice exam-style submissions for this class participation activity. I want you to write your name and your student ID at the top of your paper, just like you'll have to do for Thursday's exam. I want you to scan it to PDF using a phone app. Either Cam Scanner or Genius Scanner are recommended. Okay, I'm going to restrict the file types for submissions to PDF only to kind of force you to take that step and use a PDF scanner phone app. They are both free for the basic version, please. Class participation is going to be due by 12 noon on the assigned lecture day, which again is Tuesday, March 31st. I'll make sure that as soon as this video is posted that I have opened up class participation. If you want to do it a little early, I am totally fine with that, but the latest that we will accept it is 12 noon on Tuesday, March 31st. Please go ahead and submit practice exam problem number 1 from this lecture. Okay, the last part of this lecture is going to talk about how the exam on Thursday is going to work. We want to make sure that you guys are as comfortable as possible with how the exam is going to proceed so that you can focus on the actual exam content. We don't want this to be more stressful than it needs to be. We understand that everybody's been under a lot of stress already because of the move to online classes, because of whatever is happening in your family and your personal life and the world in general. We don't want to contribute to that by having a very stressful online exam. So we're going to do a couple things to prepare you for that. One is I'm going to talk now about how the exam is going to proceed. And the second thing is we're going to have a mock exam time for you to go in, to log into your proctored session and to get yourself situated, okay, so that there's no surprises when we take the exam. The exam period on Thursday is from 9:30 a.m. to 10:45 a.m. 10:45 a.m. on Thursday, April 2nd. Okay, 9:30 to 10:45 a.m. Okay. You're going to log into your Zoom session no later than 9:15 a.m., please. We need to check you in. We expect you to exit your Zoom session by 11 a.m., so just 15 minutes after 10:45 a.m. Okay, you must stay in your session the entire time. We're doing this so that everybody has, there's fairness applied across the entire exam period. Okay, if you want to read a novel or something at the end, bring a book. We won't let you be on your electronic devices, but you can just kind of sit there if you're finishing early, okay? It's a good opportunity to check your work, honestly, folks. Okay, there is a strongly recommended practice session with your proctor from 10:15 to 10:45 a.m. today. Okay, so again, I'm making the assumption that you're listening to this lecture on Tuesday, March 31st. Some of you may be listening early. Just make sure that you take advantage of this practice session, 10:15 to 10:45. You're going to use the same Zoom link as provided for the exam. Okay, so you're going to get an email from your proctor that says, hello, here's the link for you to log into your exam period. We're going to practice logging in 10:15 to 10:45 on Tuesday, March 31st. You'll practice check-in, you'll practice getting into the exam ready position, and there'll be no surprises then come Thursday, okay? If you haven't done so already, I need you to immediately watch this YouTube video to prepare yourself for your online exam experience. Okay, so this video will walk you through everything, including how to get into certain positions so that we can fairly proctor your exam, okay? So make sure that you watch that video if you haven't already. Okay. Here's some additional terms for our particular exam, Exam 1 of MEEG102. Okay, this is going to be the first page of your exam packet. Will also contain all of this, but I want to show it to you a little early, so if you want to put me on pause and really absorb what I'm saying here, go for it. The exam is going to be proctored by Zoom, okay? You should have watched the video. Okay, that video is the same video link I'm providing here. And at the end of the video, it's asking you to complete an honor code survey, okay? The necessary supplies for MEEG102 are multiple sheets of blank paper. I want to see blank paper, guys. 1 sheet of isometric paper. You can print out that isometric paper at /resources on our Canvas page. Okay, if you're having trouble, you don't have access to a printer, what I would do in that instance is kind of create some simple grids of your own in advance, okay, using a ruler. We're going to be very generous on the isometric problem, recognizing that not everybody may have access to a printer, but if you do have access to a printer, go ahead and print out a sheet of that isometric paper, okay? Calculators, I'm fine with any model that you have, and then obviously writing implements, okay? I used a pencil and an eraser for the entire exam. We do not expect you to go back over in pen, but we do just want to see that you have, we can clearly distinguish between your final lines on the paper and some draft lines, so make sure you're erasing. The exam is open notes, okay, so you're welcome to use any notes that you have, but your notes must be in paper form, okay, so we can't have you checking online on the Canvas site to look at a particular lecture or something, so make sure if you need whatever notes that you need, you've gone back through my lectures, you've written them down, you will have access to all of that, but you're not going to have any electronic devices to access notes. Things that are not permitted, I don't want to see rulers and compasses, okay? I also don't want to see engineering graph paper. Blank pieces of paper, you can definitely find them, okay? Blank paper. You're also permitted, in terms of blank paper, to use your notebook from the class. If you followed my recommendations in the beginning of the semester, I asked you to get a notebook that has blank pages. You're welcome to take your exam in that notebook. In terms of electronic devices, cell phones are permitted only to scan your work to PDF at the end of the exam. So we're going to ask you, the proctors are going to be very picky about where is your cell phone during the exam period. Okay, and when we do final checkout, they will permit you to pick up the cell phone to take images of your work, scan to PDF, and then submit them. Laptops and tablets are permitted only to view the exam packet. So you're going to have a laptop or a tablet that has a webcam. We're going to be able to see you, and we're assuming and we're monitoring that you are just looking at the exam packet on Canvas. So the exam packet will be released through Canvas starting at 9:30 a.m. So 9:30 a.m. start, the exam packet is released. You're able to view it, but then you're working on blank paper on the side of your exam there, okay? You're going to follow all proctor instructions during the exam period. They are in constant communication with our lead TAs and also with me. So I am there. I am not proctoring a session, but I am floating between sessions, addressing any questions people may have. And the TAs and I, the proctors and I, are in constant communication using a back channel. We communicate using GroupMe, okay? So don't worry, I am there. I am reachable. And the proctors are very experienced and well-trained. So we've got you, okay? At the end of the exam, you're going to submit your exam as a PDF file to Canvas when instructed. Again, this is very important. The proctor is going to tell you exactly when the exam is over, and you can start scanning your papers. We want to see your name and your student ID handwritten at the top of each page that you are submitting. Okay, so please make sure that you write that down. We're going to be very particular on that, and then you're going to scan to PDF. Okay, if you're watching me on Tuesday, March 31st, hopefully now it's time for you to log into your practice Zoom session. So again, 10:15 a.m. to 10:45 a.m. on Tuesday, March 31st, we're holding practice sessions for you to practice getting into your proctoring room or your proctored Zoom session. The proctor will address any issues that they think you might have with your setup, and you'll have 2 days to work on those issues, okay? So we're dedicating the last 30 minutes of class to you going into that proctored session. If you're watching me a little bit early, okay, make sure that you tune back in, that you get into your proctored session 10:15 to 10:45 on Tuesday, March 31st. Okay, guys, I know this is not ideal for any of us, but we'll make it through together. We're engineers, we're problem solvers. I'm proud of you, I miss you dearly, and we will see each other live next week if you so choose during those class periods, okay? So 10:30 to 11 a.m. on Tuesdays and Thursdays. I'll have a Zoom link if you wanna say hello and have any questions about class materials. Okay, stay healthy, stay sane, and appreciate all of you.